Hello and welcome to another one of D's ADD videos. Today we're going to be looking at redox reactions with oxidation numbers. Let's look at this example here. What we have to do is we have to look at this and determine our oxidation number, and then after that we have to determine what's oxidized and what's being reduced. Then you can use the ion electron method to balance. So let's see in action. What you have to do so let's see it in action. Here we have a couple free floating diatomic nonmetals. Diatomic means they're bonded to themselves, and all nonmetals exist in this nature when they're by themselves. And here we're going to have a 0 because it's a molecule. Here it's a 0 because it's a molecule. Here the net sum of the oxidation numbers must be 0 because that's a molecule, not an ion. And we have to look at our reliability list. If you refer to it, you'll see that hydrogen is on there as a +1. And then if this is to be neutral, what do we add to a +1 to get a 0? It has to be a -1. If you wanted, you could have written an equation 1 plus some unknown to give you 0. Then you subtract 1 on both sides, and you get x equals a -1. So, now the question is, do you remember your rules? Oxidation is the loss of electrons. So what does that mean? That means that the oxidation number should get more positive. You're acquiring more plus charge each time you lose an electron. And then the one that's getting more negative, you guessed it, undergoes reduction. So it's getting more negative because we're gaining electrons. So here, bromine's undergoing reduction. It's going from a 0 to a -1. And hydrogen is undergoing oxidation, giving up 1 electron to get to that +1. So let's write the half reactions and do the ion electron method. So we have H2 on one side, and we had H plus on the other side. And this was the oxidation equation. So at this point what we do is we look at the reduction equation. And that was the Br2 to Br minus. Okay. So if you remember, your electrons eventually should end up on the right side if you're doing oxidation, and the left side if you're doing reduction. So let's make it happen. What was the first step? The first step was to balance the elements that weren't hydrogen or oxygen. So if we were to do that, so this is a 2, so this must be 2. This is a hydrogen, so we don't mess with that yet. The next thing we do is balance the oxygens. So step 1 was elements that are not H or O. And then step 2 is to balance the oxygens. We'll pick gold for oxygens. And we do that by adding water. But you'll notice that there are no oxygens here. So the next thing is the hydrogens. So we balance the hydrogens by adding H pluses. So here we have 2 hydrogens, here we have 1 hydrogen, so we need to add another hydrogen. So after we've balanced the hydrogens, then we have to balance the charge. So here we have a +2, and here we have a 0. So that means to balance the charge, I would need an addition of 2 electrons there. Balancing charge by adding electrons. And then here we have a 2-, so here we have to have 2 electrons. Notice that the electrons are going on the side that I told you they should. So understanding this concept before just plowing through these problems is a good idea so that you know you're on the right track. This is your reducing agent. This is your oxidizing agent. Remember, the reducing agent gets oxidized, the oxidizing agent gets reduced. The reducing agent is the thing that gives up the electrons so that reduction can take place. The oxidizing agent is the thing that accepts the electrons so that oxidation can occur. Because the electrons were given off by the reducing agent, which is the process of oxidation. And if there's nothing out there to pick up these electrons, then we're in trouble. So the oxidizing agent picks up the electrons from the process of oxidation. So in this case, electrons do match up. You don't have to multiply by a constant. You can just add the 2 equations. So the 2 equations as they sit now are H2. I'm going to go ahead and combine those 2 H pluses plus 2 electrons, and then Br2 plus 2 electrons, 2 Br minus. So the charges should be the same on both sides. Now I add these 2 equations, and then it's balanced. All right? So it's key to have an understanding of the increase in oxidation number indicates oxidation, I've given up electrons. Decrease is reduction, I've gained electrons. Then that allows you to write the half reactions. Once you write the half reactions, you can balance the non-hydrogen and oxygen elements, then balance oxygen by adding water, then balance hydrogens by adding H+, then balance the electrons. Then you add the equations. After you add the equations, it should be balanced both by charge and by atoms. Hope I've eliminated any confusion that you might have. Practice, practice, practice. Thank you, and have a nice day.